Okay, so today I want to make a very basic version of DLL imports work with my compiler, with my linker. So currently I can only, if I look at these two link together, so this is the compilation unit 1 and compilation unit 2. And so, well, I can link these together and that tests some basic stuff about linker. But because I can't do DLL imports, there's no way I can like print anything or something like that. And so what I want to do today is make a very basic program which uses some DLL imports to just print something to standard out. Okay. And so let's make maybe new test.c, and well, it's got like a main function, probably has to import Windows. Windows.h, and then well, we want to write to standard out, and the way you do that using the Windows APIs is you have to get a handle to standard out, so std out, and you use get std handle, I think. Then you have to pass like which handle you want, which we'll Google in just a sec. And the other thing is then you go do write file. And you can write file to std out, and you have like a buffer. Use Windows notation. Say hello world, everyone's favorite program. Then we write the buffer. Can it work, please? For the size of buffer, but we will subtract the 0 terminator. I think everything else can be passed null. Okay. Then I think the standard handle, which I have right here, is standard output handle. And so this is hopefully supposed to work. So if I just do cl test.c, then test, you can see it prints hello world. Okay. So I want to be able to link whatever test.obj is, more or less. So let's look at that. You can see that there's actually quite a bunch in there. Some of it I kind of want to reduce because it does like security checks and stuff like that, which I don't want. So let's, for one, make a like build script thing. So let's call it build test, and well, add echo of del test.exe, del a.exe, which is going to be what my linker produces, and then also del test.obj, just cleaning everything, not del but del, and then running the compiler on test.c and using the linker, so the Microsoft linker to link it with some arguments, test.obj. Then I have like another test script, so we can just steal some arguments. New test.add. We want it to compile with no default lib and the entry being main, and also no dynamic base, because I have not implemented that for my compiler. So just to get these executables as we produce like up to speed, or like to be the same. And then it's also a good measure add no logo. Let's try to run that. And it's telling us unresolved and external symbols because we did no default lib. So I think get standard handle and write file should both be in kernel32.lib. So let's see if that's true. Would be good. Yes, and now we only have the security checks, which let's Google how to disable them. I think there's some option. CL disable security check cookie. /gs minus. I did this a bunch, so don't remember the particulars, but when I see them, I think this is supposed to do it now. All right, then we can see now it prints hello world. And we have a binary which only imports get standard handle and write file. Let's also look again at the object file. It should be a little bit smaller, not a lot smaller, I guess. Currently, this section, these two sections are ignored, I think, because they are discardable by my linker, and the directive section as well, but maybe we need that now. Let's see what's in there. That tells us just what we need to link with, I guess. uuid.lib, uuid.lib, libctm, and old names, apparently it wants us to link with. But we don't want to link to these, because we only have these two things that we actually care about. We care about write file and get standard handle. And what I'm just going to do, I'm assuming every import is inside kernel32.lib, and so we don't have to pass any .lib files to make this work. Okay, so this is just some hack to get started. Anyway, we have this, and now let's see what happens if I use my linker to link this. And so the way we do this, just in the, not the test.bat, because that's the other thing, the build test, just maybe not a great name. We also do linker.exe, and then we link test.obj. Let's see what that does. Error. Imp get standard handle was used but never defined. And also imp write file was used but never defined. Okay, so this is sort of exactly what I expected to happen and what I want to happen, because these two symbols are obviously never defined in the binary in any object file, but they are have to be imported. So, and how to import them? Well, first of all, I think the way this works, because if we look at the object file, is that the prefix, the --imp dash, is the only information we have to go on to know that these are DLL imports. So we're just going to detect unresolved symbols that start with --imp dash. And for now, I'm just going to collect them inside a table. Okay. So let's go into the source code of the linker. And what we care about is this like was used but never defined, because this is where the error is happening. This is happening right here. So give a little bit of context. Before I iterated over all of the object files, did then over all of the symbols in there. And if they were external symbols, which means they refer to another object file or define something, then I put them into this external symbol hash table that I have right here, which later on helps me to link them up. And then after I did that, I iterate over the entire symbol again. And if I find a symbol which was defined, which was not defined, but obviously referred to, then, well, I don't think I check if it's referred to by any other thing, but if it's a symbol, then that's sort of a reference to it, I guess, is what I'm thinking. Anyway, so if it's a symbol in any object file, but there was never a definition and also no size associated with it, then I assume that the thing is an external symbol which was never defined. Okay. And here I'm just going to put in a little hack, like we said. So each of these external symbols, I think, has a name. Right here. So yeah, if there is no name, so I check out here. And so I'm just going to check if this name of the symbol starts with dash dash imp whatever. So if the symbol name size is bigger than whatever, what do we have? 1 imp dash. It's bigger than the size of this. -1 because of the null terminator. And we have str comp of symbol name dot data and str ncomp, I guess, because I only want these 5 characters or whatever. Dash dash imp dash of size of this -1 is 0. This symbol is a DLL import. All right, and this is obviously not going to fix anything, but let's just see what's happening if I run this. I build I have to first build the linker. That makes sense. Oh, it crashes. Maybe that's good. Let's type build, get this command, and run it in Remedy. See where it crashes. Maybe it tells us what we have to care about here. All right, so it crashes when later on I'm trying to fill in a relocation, and the relocations assumes that I could find the external symbol in the in the external symbol hash table. So yeah, this is sort of the spot where we want to fill in something as well, because if we found the symbol, that means it's in some other, or like we found a symbol that is defined, that means it's in some other compilation unit, and we can link to that. If we found it but it's not defined, that means we have added it to the BSS section, so it's a symbol that has no value, I guess, associated to it. So it's an uninitialized symbol, which means it's 0 initialized, which means we put it into the BSS section. But now we also have these symbols that are DLL imports. So let's maybe add this field to the external symbol and see from there. And so here I'm just going to say symbol DLL import maybe. I kind of want an index into the import section later on. Maybe an index or just an offset already. So, but currently here we don't know where anything is. So we would have to have an index. To maybe show this, how this works, if it works, in the test.exe, which was the executable produced with link.exe. Then I want to dump the imports. You can see this is how it's supposed to look in the end. There's a kernel32.dll, which is an import section, which is one of these here. There's an import directory referred to by the optional header, which points to just some RVA into it. So this is probably in the RData section somewhere. At least this is where I'm going to put it. And in the end, this is just some table. So if you look at the PE spec, import, not important, import table. No. The iData section. Maybe I should just make an iData section. Yeah, we have to fill this out when we actually write the import directory table. But as you can see here, here, these, in the end, this is just some array. So for each DLL we import, we assume every import is in kernel32.dll. We get a list, an array of imports. So I think the way I'm going to do it is, when this is a DLL import, I am going to allocate a linearly allocate an index into this table. These, to make sure that they're always non-zero. Actually, maybe I don't need to do that. Okay, let's say DLL import index, or is DLL import is 1, and then DLL import index. Import index is DLL import index plus plus. Then we have another variable here, DLL import index. Starts out at 0. So then we have to add these variables to the external symbol. And yeah, currently I'm not trying to keep this small or anything. So we're just trying to say int is DLL import, and made it U64, but let's say U32, DLL import index, and then I should maybe also make this U32, whatever. Okay, and now where we crashed before, somewhere here, like found is defined or something, we can detect if found is indeed an DLL import, is DLL import. And then we have to somehow compute a symbol relative virtual address right here. Virtual address. And well, we don't know this yet, but just to get something wrong working, I'm just going to choose 0. Or let's choose this like found DLL import index. Maybe 4 times that. Then let's see what that does, if that gives us an executable. And it does, and if I run it, it crashes. That's good. So obviously I don't have debug information, but we can look at the disassembly. And then we can see how this sort of works. Is here's the call stack, and then it calls this function right here, which is RIP minus 3012, which after this call we had 3012, so this calls the start of the image, which is sort of what I put in for the first index, and this call right here calls 34E, which, if this one is the RIP at this call, is, well, 52 minus 4E, which I think is 4, which it should be. Let's, do I have Python? No. Don't have Python. Can this guy do it? OX 52 minus OX 4E. 4. Okay. So now we sort of understand what we have to patch in. So we have to patch in these, like where we patch them in and what is happening. Now we have to build the table which actually does the correct thing. So which gets resolved doing the loading of the program. And again, this is this iData table, iData section right here, import directory table, and yeah. Let's maybe look at that. So first of all, the import directory begins with the import directory table, which describes the remainder of the import's information. The import directory table contains the address information that is used to resolve fix-ups, references, and entry points within DLL image. The import variable consists of an array of import directory entries, one entry for each DLL. So this guy tells us the DLLs they're in, so we need one of these, which the image refers to. The last directory entry is empty, filled with null values, which indicates the end of the directory table. Okay. And so this contains another RVA, so another relative virtual address, which is a relative virtual address to the import lookup table, which this guy, the import lookup table, actually contains the name and the ordinal of the imports that we have to put in there. Name, yeah, hin name table RVA. For hin name table, this field is only used if the ordinal bit flag is 0. We want that. Or yeah. Okay. Then let's first off write out these values right here. In the linker, we want to, once we know everything, where everything is, sort of, where we allocate the BSS section. So right here, what I do is allocate a BSS section if one does not already exist and we need space for uninitialized externals. And so, yeah, this is something for uninitialized externals. We sort of want to do the same thing for the RData section and DLL imports. So let's go right here and say allocate a .rdata section if it does not already exist, and we need space for the DLL imports. So structs conf section header image RData section header. It starts out at 0. Do also need these uninitialized externals, BSS start sort of equivalent. So this is the imports. Imports RData start, maybe something like this. And what this is going to refer to, because again, we're only gonna keep one array for now, which is, it's going to have the lookup, import lookup table, because we assume that there's only one of these. So maybe let's call it that as well then. So import lookup table RData start. And so if we want to know if we have any DLL imports, and we can do that by checking the index. So DLL imports index, yeah, this guy. This is not 0, that means there was a DLL import. Then we are going to linearly search through the sections, trying to find one that is called RData. So BSS data, and if we don't have one, then wait, BSS. Why did this not work? Place and range, BSS data. Must have had a different range or something. So if we don't have it, we allocate a section header for it. We set the name to rdata. 1, 2, 3, 4, 5, 6, 7, 8. We need to compute a size. And then we also need to figure out how to initialize it after. Because currently I only stitch together the other sections. Right here. I go over the sections of the object files and stitch them together. But this is like some extra data inserted by the linker, sort of. So I have to do that somewhere else. But let's not care about that for now. The characteristics of the R data, I'm just going to copy from the characteristics that they have for test.exe. So let's again do Dumpbin test.exe. And I want headers. Then I have an rdata section right here, and these are the flags. This is what I want. Okay, and then there is an additional image section. So the size of raw data right here sort of have to figure out. And so if we have one, so here where we allocate virtual addresses, I guess we want an rdata offset. So we have to figure out later where we want to write our actual data, which is going to be the import directory table. So we can figure out the size of this. It's going to be 20 non-hex. And then per import one of these guys, which I think is an array of 32-bit numbers, an array of 64-bit numbers for PA32 plus, which we are. So 64-bit numbers. So the size, do these have to be aligned? Maybe just make sure that they are aligned. R data import offset start at 0. In this case it can stay 0, and in this case we set it to, wait, this says last image section. Probably shouldn't say last image section. It's probably a bug in here. Because we figured out what the BSS section is, so probably the one we care about. I'm just gonna make the executed decision that that was a bug and that we've also fixed it in here. Oh yeah, and the start is the same thing that I wanted to do with rdata import offset right here. Okay. Right, now we have to figure out the size of what we need. And the size, and looking at this, we need one of these import directory tables, or whatever it's called, with data in it. And then it said that we need to put an empty one after it. So we need 2 of these. So 2 times 20 bytes. We need the import table lookup. So this is 64 bits per number in this. And the last entry is also set to null to indicate the end of the table. And that doesn't say anything about alignment, but we're gonna assume it's aligned. And then afterwards, we also need space for all of the names. So we're going to need all right. So there is an import address table as well. So there are 2 tables we need to fill out. The hint name table. One hint name table suffices for the entire import section. Each entry in the hint name table has the following format. A hint, an index into the export name table. So this is an ordinal thing, maybe, and then the string of the name and the trailing 0. Okay. And we're gonna set all the hints to 0, so let's not worry about that. But that means we should probably allocate this table somewhere while we are emitting the indices. And then the import address table, the structure contains the import address table. They're identical to the import lookup table until the image is bound. So we're going to need 2 times the size of this import lookup table. Okay. Let's try to do that. That screwed up everything. That's great. Import library format. No, I don't care about that. Trust me. That's what I'm trying to avoid by fixing anything to be in kernel32.lib. But anyway, here we are. So the rdata size is something like 2 times size of import directory table entry plus 2 times the size of the import lookup table, which is, let's say, import lookup plus so it's the import, it's 2 times because it's the import lookup table and import address table times the 8 times the size or the DLL import index. And then we need size for all of the strings. And the size for the name RVA. Not the RVA, but the name. So plus size of kernel 32.dll plus these RVAs, and this is 2 plus, which I'm just going to name hint table. So size of name hint table. The size of the named hint table I'm just going to compute up here. Where we looked up the DLL imports. So the size of the name hint table is 2 plus the symbol name dot size plus 1 for the null terminator plus it says 0 or 1 bytes of padding, so trailing null bytes appears after the trailing null byte if necessary to align the next entry on an even boundary. So if this size was unaligned right here, then we need to add 1 null byte. Okay, and so this should be the size of the import table. So I call it our data size. Let's rename that. Let's maybe call that the address info DLL import information size or something. Okay. Now, we can try to write all of these fields that we need to care about. Let's actually make this a little bit bigger because it's probably barely readable. And that is way too late that I did that, but whatever. iData, not eData, iData. Now, writing these in. So here, this giant thing writes out all of the section data. But we already know where everything is up here. And we sort of need to, I guess maybe we don't, but kind of doesn't matter if we do it before we write in all of the section data for the object files or after. But maybe let's do it before. So the way this would work is First off, we make a comment and maybe a scope for good measure. Write in the DLL import information size, which I have right here, the DLL import information. And we have the size, which I guess we don't really care about here. Search for that again though. We need the offset. So import lookup table rdata start is what we care about. And we also have the rdata section. Image rdata section header. And so this has a pointer to raw data on it. It's just the offset in the final executable. So the final executable starts at image base. So this is the import lookup table. I like DLL information. Let's call it DLL information base. Import information base. Really can't type, holy fuck. Okay. Let's get like a check size maybe. Let's not. So the first two things we have to put in are these import directory table. And the layout, let's maybe look at the layout again. This is what sort of what we decided on is we have first of all the import directory table. Then we have a null import directory table. Let's lowercase it. And then we have the import lookup table. Then we have the import address table. Then we have kernel 32.dll. Let's actually put that at the very end. No, I don't need to fix it here. So we have the size or name hint table. Name hint table we have here. Then in the event, the kernel 32.dll. At these offsets, so this is at offset 0, this is at offset 20, this is at 40 plus, this is at offset 40, this is at 40 plus 8 times DLL import index, and this is then at 40 plus 16 times DLL import index. Oh, and this is at this thing plus the size of name hint table. Maybe I should have swapped those around. Is there a good macro way to do that? Maybe there is. Oh no, what am I doing? I want to align these now. Align. Pressing all the wrong buttons. 3, thank you. Align these. This looks okay. I think this looks a little bit better. Anyway, doesn't really matter. So let's do struct import directory table entry. This has the import lookup table RVA. And the time date stamp. The forwarder chain. Name RVA. And the import address table RVA. And this starts out, so this is the import table entry. This is just at the start of the import information base, DLL import information base. And we know all these values because we have the offsets right here, and then we only need the relative virtual address of the image data section, which we've already computed. So import table entry, import lookup table RVA is the image data section header. Relative, I think it's just virtual address for some reason, plus, well, which one is this? Import lookup table RVA, which is this guy. So plus 40. Then the name RVA, well, let's do the import address table first, which is 40 plus 8 times DLL import index, which DLL import index obviously at this point is just the amount of DLL imports. And then the name RVA is this kernel 32, which I think is to a name RVA. This way around. Which just take this whole computation and put it in here, but we also need the image relative virtual address of the thing, the data section. So time date stamp and forwarder chain I think can both be just 0, but let's see what they do. I guess I want imports. You can see time date stamp is 0, index of first forwarder reference is also 0. So this is exactly what we are doing. Now the import lookup table and the let's get these other values out of here. So use 64 import lookup table is the base of the information plus the offset of the information, which we've already calculated right there, which is 40. And then the import address table is 40 plus 8 times the DLL import index. Again, pretty repetitive math. Maybe we could put these out in offset variables, but whatever. Let's keep it like this. We know that these have to be the same. So after we calculated this guy, we can just memcopy from this into the address table for 8 times DLL import size. And then the import lookup table, the RVA of the import lookup, no, I care about this guy. If this bit is set, import by ordinal. We don't want to import by ordinal. Otherwise, import by name. So this is the top bit. So we don't want to have this top bit set. We can do that. Then either there are 16 bits of an ordinal number or 32 bits or 31 bits of an RVA of a name hint name table entry. But this is an RVA, which is interesting. Okay. So the way we do this, then we have to find all of the DLL imports again, because I didn't save them. We are just going to do the same iteration that we did up here, which is not great, but who cares? So we kind of want this. But we don't care about if the symbol has a name, which is just non-empty, but we care about if the is DLL import is flag is set. So in this case, if the DLL import flag is set, then we want to write, so let's say 32. No, we know the index because it has this symbol DLL import index. Then we need the RVA of the RVA of a hint name table entry. So name hint table entry RVA. And we also want to fill in at the same time the name hint table as well. So let's get the address of that. Should be at this offset. I don't need to cast that right now. Let's call this the name hint table base. Then name hint table offset, let's call it at, And also to fill this name hint table entry RVA, we also need to know where the name hint table RVA is. So let's also compute that, which is just the name hint table RVA is just the same as above here. We take the virtual address of the RData section and we add the offset within the RData section, which we know is right this. It's this thing right here. And so the name hint table RVA is the name hint table RVA plus the offset of the entry. Maybe we call this guy the offset then. Name hint table offset entry offset at. Very good name. Okay. Right, and we compute that all the way up here, so then once we patch it, we can patch it down here. And where do we want to write? We want to write into the name hint base whatever plus the offset at +2. And +2 is because the name hint table starts out with this 2-byte hint, which is just going to be 0 for us. And so this is the name. We're going to mem copy into the name, the symbol data, name data, symbol name size. We use here that everything it defaults to 0, so we only have to write the data that we actually care about. And then we have to calculate here the same size again that we did above. So this is 2 for the hint plus the size of the name plus 1 plus this guy and 1 to get the padding byte. Okay. So let's make sure we have filled everything in. So we have these import directory table, which we filled in right here. We have the import lookup table and import address table, which we filled in in this loop and then in this mem copy. And we filled in the name hint table right here. But what's missing is the kernel32.dll. So let's also add that. So at the very end here, add this ridiculous offset right here. Create name RVA, no name. Let's say kernel32 is import table entry, no, DLL information, this is what I want, DLL information base plus all of this crap. Now, last thing is to actually fill it out. Okay. Now, we have not actually filled in this table, the the relative virtual address is down here. So where I've put the to do. Right here. But let's not do it right now and just look what Dumpbin tells us about. Well, first make it compile, but then after we make a compile, we are going to ask Dumpbin what it thinks about our table. And actually, there's also one more thing missing. Namely, right now this is just some random table inside the RData section, but the header does not refer to it. So let's make the header refer to it. And I think we already have the header, so we can just fill it in right now. Optional. Yeah, here the optional header. And the optional header has these directories, which have a virtual address and a size. Oh, and I noticed that I'm screwing up one more thing. But let's plow forward for now. So the data directory of which one is it? In / headers test.exe. It is 0, 1. And the virtual address is, interesting that I call it virtual address. It's a relative virtual address, but let's keep for now. The thing that I'm screwing up is I'm just taking the virtual address out here, but I want the virtual address of the image, which is this guy. So I need the offset as well. So let's copy that. Pointer, let's call it just DLL import information pointer to raw data. Is this it? Is this what I want? I think so. No, wait. I want the relative virtual address. Information, which is spelled wrong. Relative virtual address. So what this is not the pointer to raw data, but the virtual address. So whenever I filled in these virtual addresses down here, let's make this big. I took the wrong one. I just took the virtual address of the section, but I neglected the offset. So let's fill these in right here. Just using this instead. Oh, maybe that's correct. We'll see. So we patch in the virtual address, which is a relative virtual address, which we've just calculated, and then the size we knew from a long time ago. Which is somewhere. Start. Oh, I only have it calculated right here. Let's pull that out, maybe. Sure. Set it to 0 to start with. And then fill it in right here. Size is the size which we calculated for the DLL import information. Okay. Now, moment of truth 1. Let's see what Dumpbin thinks. So first of all, it compiles, that's good. Thinks about this. So build, test. Do we crash? No. Dumpbin a.exe. This looks good. And we have an RData section. And let's dump all of the information. And oh, this is looking very nice. Section contains the following imports. We contain import get standard handle, import write file, import get standard handle, import write file. Okay. So first of all, we have to strip the --imp thing. And then why are they here twice? Oh, because I forgot that I need to end the array with a 0. So there's also +1 everywhere. Now I have to fix up everything, which makes me sad that I didn't calculate the offsets beforehand, so let's do that. Actually, you can just patch DLL import index. Let's call this a hack because it is. The import lookup table and the import name, import address need a 0 terminator. Then where we calculate the size, we also need to be aware of that. So and then because we decided to order these in the other way, let's also do this. Right, almost there. Now that should be fixed. That is looking good now. So these zeros, these are fine. This is the hint that I'm not filling in, which I don't care about. So now the only thing we have to care about is stripping the --imp dash. But we can do that. The symbol size is the symbol size minus size of dash dash imp dash -1. And instead of using symbol right here, I'm going to use this symbol size. And then the same thing for the symbol size below. Maybe I'm calling it that. Wait, it should be this. Name. Right here, blub, blub, this guy. Here we can just add the size of non-import name is data is symbol name data plus this, and the size is sort of the same thing, but instead of data is the size, and we subtract this value. Alright, now, finally, should be there. Hello world! No, wait, it's the wrong thing. Right, we should still not be able to run, but what I wanted to test to see is how the import looks now. We can see now it says get standard handle and write file, exactly like I want. So if I look at the same thing on test.exe, you can see this looks very similar now. Okay, now one last thing is to figure out the relative virtual addresses so that we actually patch in, when we apply the relocation, that we actually patch in the value that we want. So right here where we started. Now this should be the relative virtual address of, I think, the import address table entry. Relative virtual of the import address table entry. Let's make sure that it's the import address table and not the import lookup table. So this has these two tables, the import lookup table, the RVA of an import lookup table. This table contains the name and ordinal of each input. And then the import address table, the import address table. The contents of this table are identical to the contents of the import lookup table until the image is bound. So when the image is bound, this import address table is filled in by the dynamic loader and contains the actual addresses of the DLL imports, which this is where we want to point our relocations to. And so we need the relative virtual address of the address table So let's say import address table relative virtual address. And then we could calculate it here again, but I'm just going to assume I have this. And then I add 8 times the found DLL import index. This is our symbol relative virtual address. So just assign this. Import port address table. So right here somewhere we have the import address table RVA. Yeah, this is actually we sort of have this, but not really. But this is what we want. I'm just going to make a variable right here. So one thing I forgot here is that all of this should only happen if there are DLL imports. Because if there's no DLL import information, we don't have to write it in. So if this is unequal to 0. Okay. Testing that is maybe another time. Let's build this. Let's see if we can still build. We can. Let's look at it in Dumpbin again. Dumpbin a.exe. You can see nothing changed. It makes sense. So I guess let's ship it. And it prints hello world. So that works. Maybe one quick look into RemedyBG, but actually, to really make sure this is working, we could delete the binary again. Del a.exe. And then linker test.obj. Hey, but it is working. That's very nice. Okay, so that was it then. I hope you learned something. I hope someone enjoyed this. Now it can access DLL imports only from kernel32.dll, but I think for this linker, which is just supposed to be a toy linker project, this is all I care about. So thank you very much for watching, and yeah, maybe see you again if you enjoyed this.